In this video, we will be looking at completing the square. To graph any quadratic function of the form ax squared plus bx plus c equals 0, we rearrange the function in the vertex form as shown, using the completing the square method. The coordinates of the vertex, that is, the minimum point and the maximum point, is gotten or given by h, k. Notice that the h here and the one we have in the bracket here, the signs are opposite. So if we have a plus, we switch in here. The sign of k remains the same. Quick recap or note. When a is less than 0, that is, the coefficient of x squared is less than 0, which means it is negative, we have a maximum point. You could see the shape here, N shape. When the coefficient of x squared is greater than 0, that is a positive value, we have a minimum point, that is a U shape, as shown. Having established this, now let's look at an example. Write y equals x squared minus 4x plus 1 in the form y equals x minus h all squared plus k, stating the coordinates of the vertex. We need to establish that the value of a in this scenario is 1. So, step 1. We identify the coefficient of x. And we can clearly see that the coefficient of x here is minus 4. Step 2. We divide the coefficient of x by 2. That is, we have minus 4 over 2, giving us negative 2. Step 3. We square the results of step 2. So we would have minus 2 squared. Please, at this level, be keen not to calculate this value. We leave it the way it is for future reference. Step 4. We add and subtract. Notice the order. We add first and then we subtract the result of step 3 to the quadratic equation. Perfect. If we do this, what do we get? Let's go to the next page. We get x squared minus 4x plus negative 2 all squared plus 1 minus negative 2 all squared. Notice we add and subtract. So basically, we are not changing the equation or the expression. Now, from this point, we produce a bracket to form a perfect square. This becomes x. We have minus 2 all squared plus 1 minus 4. Y equals this, y equals this. So this simplifies to y equals x minus 2 all squared minus 3, because 1 minus 4 is negative 3. So we have rewritten our equation in the vertex form using completing the square method. Now we need to state the coordinates of the vertex. So the coordinates of the vertex would be, notice here we have negative 2, so we put the opposite sign 2, and we maintain the sign of k, which is negative 3. At this point, I'm sure we're very clear about what we have to do. Now let's look at example number 2, hoping to clarify even further. Solution. We rewrite the expression y equals x squared plus 2x plus 5. We remember our step 1. We identify the coordinates of x. And we also notice that the coefficient of x squared is 1. All right. So step 2. We divide the coefficient divide by 2. This would give us 1. Step 3. We square the result. So we square the result. Step 4. We add and subtract. So the equation becomes x squared plus 2x. We add plus 1 squared plus 5. And then we subtract minus 1 squared. Having done this, our equation reduces to a perfect square on one side. This part reduces to a perfect square. So now we have x plus 1 all squared plus 5 minus 1. This reduces to x plus 1 all squared plus 4. This is the vertex 4. All we have to do is to state the coordinates of the vertex. The coordinates of the vertex would be, here we have plus 1, flip it over, or we flip the sign, it becomes minus 1. And here we have 4, keep it as 4. That is the coordinate of the vertex. At this point, I'm sure we are all satisfied. Now let's put this knowledge into practice. Your practice task would be to write y equals x squared minus 6x plus 3 in the form y equals x minus h plus k and state the coordinates of the vertex. All right.